All right, guys, so we're going to have our first lecture. It's going to be on types of graphs and their uses. So these are the 5 graphs that we're going to go over quickly, but we're only going to focus on learning how to do one of them, and that is going to be the line graphs, because those are the most applicable to having an independent and a dependent variable and how they will rate to each other. And if you don't know what that means right now, it's fine, because that's something we'll be going over. What I would like you to do right now is to go ahead and put the video on pause. Go ahead and copy this slide. This is the only slide I'm going to have you copy right now, and then we're going to get into the details of how to make a line graph and how to identify those variables that I just mentioned. So like I said, pause, copy, come back. Okay, so I'm going to just go ahead and jump in to these different types of graphs by showing you examples and discussing them. Okay, the first one we have is pictogram. A pictogram, as you can see, is a way of representing data with a picture, basically. So over here we have the example, and not really sure what this scenario was representing, so I'm going to make something up. I'm going to say this is the number of people in different countries that like the color blue. Okay, so if I wanted a visually interesting yet fairly simplistic way of representing how many people in different countries like the color blue, I might do something like this with a pictogram. As we can see right here, each one of these figures represents a certain number of people. Okay, and in pictograms that's usually the case. The item, the visual item, here it's a little person, either represents a single person or a single object, or it can represent a specific number. Here, each of the little people represents 10 people, each of the little person picture or object. Okay, so according to this, there would be 10, 20, 30, 40, 50 people in France that like the color blue. In Italy, it would be 60, Spain would be 30, etc. Okay, there was pictogram, then there was bar graph. Thing about bar graphs is the bars represent categories. They don't represent a numerical data. Okay, so right here, and the other thing is the data is not related to each other. So here there is the number of people that are indicating what they think the nicest fruit is. How many people like an apple for the nicest fruit and how many people like an orange for the nicest fruit? They're not impacted by one another. Like people either like the apple or people like the orange. But how many people like the apple doesn't impact how many people like the orange. So these categories do not intertwine with each other. They do not impact each other in any way. So here we've got the other thing that you can tell about bar graphs is we can see that people think that the blueberries, the majority of people like blueberries as the nicest fruit, as the number one category, and we can see that by the height of the bar. How many people that would be, we would go over here and we would say, oh, that's 40 people. Okay, notice that the bars do not touch. Okay, when you have categorical information, the bars do not touch. That's different than a histogram, which is one of the ones we'll look at. So here we go. Bar graphs are used for categorical information, and the numbers are independent of each other. That's what I was saying, where the number of people that like the apple don't impact the number of people that like the orange. The numbers are independent of each other. They're not related. Okay, that is different than the histogram. Notice that in a histogram, it looks a lot like a bar graph. However, on a histogram, instead of having categories, what you have are ranges of numbers. So on here, it says a histogram is a graphical method for displaying the shape of a distribution. In super simple terms, it represents the shape of the data, like what the pattern of the data is. You know, where your high values are, where your low values are. Okay, so on here we have the heights of blackberry trees, black cherry trees, and the frequency at which these different heights occur, like maybe say in some forest or something, I don't know. Okay, so here there's a range from 60 to 65. There were 3 trees. Now, what were the heights of those 3 trees? Without looking at a raw data table, we don't know. We simply know that there were 3 trees that were between the heights of 60 and 65 inches tall. I'm sorry, feet tall. 60 inches tall, that would be like 5 feet. That's still taller than me. Okay, so moving on. So then there were also 3 trees between the heights of 65 and 70. We could also see from this data that the majority of the trees, 10 trees that were measuring between 75 and 80. These bars, if you will, are not independent of each other because these are all trees in the same area, but they represent a quantity within the forest that we might be talking about, and it represents a range of how many trees occurred at the different heights. Okay, so here we have pie charts, and we have energy consumption by sector. Okay, so what this represents is the residential housing and things like that. How much of the energy did they use? And so here it's 7% of the total energy. For like transportation used 28% of all the energy. The industrial business used 22% of all the energy consumption. Electricity used 39% of the total consumption. And then we have commercial, like the little stores, fast food, restaurants, things like that, used 4%. So what the way this is created is you take all of your raw data. You might start by putting it in some type of chart, and then you make your different categories. Here, the different categories are the electricity, transportation, industrial, and you figure out how much they represent as part of the whole. Should be. We're really not going to be doing any pie charts, but this is just, a review of graphs, different types of graphs in general. Okay, line graphs. Line graphs are the ones that we are going to focus on. You already made your practice graph. The reason why science, you can use a lot of different graphs for science, but the reason why we're going to be focusing on line graphs, the main reason is because it is a relationship between the independent and the dependent variable. So line graphs are used when data is connected, okay, so like I just said, between the independent and dependent variable, to show trends or to show how numbers can change over time. So for example, if we look at this first one right here, and we've got the sound level and the number of students, you can see that as the number of students increases, the sound in the cafeteria also increases. So those two things are related. How much sound there is in the cafeteria is directly related to how many students are walking in. And the more students walk in, the louder it's going to be. So we wouldn't use something like a bar graph for that. Bar graph, because bar graphs show categorical data. They're not related to each other. But here, we're looking for a pattern. As there's more students, is the sound the same? Is the sound increased? Is the sound decreased? We're looking for some kind of a relationship in showing how those two things might be connected. Right here you have solubility of different types of salts. Okay, a salt is just anything that hopefully you remember this from your chemistry in 9th grade. Is that a salt is not just the table salt you put on your food, but rather a metal that is bonded to a nonmetal. So here we have sodium nitrate. Sodium is going to be your metal, and the nitrate group is going to be your non-metal ion. Here we have calcium chloride. Calcium is your metal, chlorine is your non-metal, etc. So what we have is we're showing that as the temperatures, what we're trying to look at is what's the pattern as the temperature increases, what happens to the solubilities of these different salts. So let's focus on the one that we put on our food. The one we put on our food is right here, sodium chloride. Okay, this one that's kind of in this light blue. So what you'll notice is that as the temperature increases, how much salt you can get to dissolve in the water slightly increases. Okay? However, there are some that are more drastic. Let's look at like this potassium nitrate right here. Look at this. As the temperature increases, look at how much more potassium nitrate can be dissolved in water. We have this one right here. So this one shows the relationship that as you increase the hours, the number of hours that you exercise per week, how that may have an impact on your resting heart rate. So if you exercise 1 hour per week, your resting heart rate might be somewhere around 75. Okay? Then as you increase the number of hours of exercise that you do per week, this is indicating that your resting heart rate may decrease. Okay, right here for all three of these, what we're trying to do is show that relationship between two things. Here, the relationship between the number of students and how loud it is in the cafeteria. Here, the increase in temperature, how that impacts the solubility of dissolving a salt in water. Or here, as you increase the number of hours you exercise per week, the impact that may have on your resting heart rate. So all these pieces of data are connected to each other, and that's why we use a line graph to graph and interpret the results, and that's why we focus on this kind of graph quite a bit in science.